Hey class, back in the basement again. Kids are sleeping, so today we're going to talk about measurement. And it's August 10th, and hopefully you're still having a great summer. And when you receive this, hopefully you're not too shocked that you're already learning science before school starts. But the topic for today is measurement, and after this video we'll talk about data analysis and some techniques on graphing and analyzing graphs and data. But for today's measurement, so let's look at the topics that we're going to discuss. The SI versus the metric system, base versus derived units, Common English versus SI units, metric prefixes and the conversions, scientific notation and the modes on your calculator, as well as unit conversions by hand and on the calculator, and lastly, dimensional analysis. I realize some of these topics are going to be familiar to you, and feel free to fast forward through the video or just listen without writing things down. However, I do suggest you have a notebook and something to write with and jot down as much information as you can. It's always easier to go back through your notebook and review notes rather than going back to the video. However, the videos will always be there for you. You can go back and review what I said and review the slides. That way you're able to gather as much information as you can. Alright, so the SI system is based on the powers of 10, meaning as we increase the sizes of our numbers, they increase by one digit each increment. And so this is the power of 10. And it's used exclusively by most all other countries. The United States uses the English system, and mostly because of the history of manufacturing in the United States, it's very difficult to change the system. Alright, so in 1866 it was declared the official system of measurement by most other countries, and in 1975 there were laws that were passed to promote more extensive use. And if you travel to Canada, you realize that they don't measure speeds in miles per hour like they do in the US. They measure things in kilometers per hour, which is the metric system. Well, the SI system, you'll notice, is just a little bit different than the metric system. Alright, base units versus derived units. A base unit of measure is the lowest common denominator of a unit. And there are 7 base or fundamental units in physics, actually in all of science. And here they are. Length is the meter. Mass is measured in kilograms. Time is measured in seconds. Temperature is measured in Kelvin. Amount of substance is measured in moles. Current is measured in amperes. And luminous intensity is measured in candelas. And these are the symbols that go along with them. So these are the base fundamental units. And derived units use 2 or more of these units and combine them together in one. For example, if you're going to measure speed or velocity, you're going to need a unit of length and a unit of time. So you use meters and seconds to get meters per second is the derived SI derived unit for speed. And as we get into more units and equations, I'll give you a whole list of derived units. Alright, so comparing common SI units versus English units. When we measure length in the United States, we always talk about inches, feet, miles. Well, in the scientific community, they don't use inches, feet, and miles. They use meters and kilometers. And there's several other prefixes that are attached to the base unit of meters. Instead of using slugs, which you probably never heard of, but that's the English unit for mass, you're probably familiar with the English unit of weight, which is pounds, but the English unit of mass is the slug. And in the scientific community, they use kilograms. And you'll notice if you go to pretty much any other country and you ask somebody how much they weigh, they're going to give you an answer in kilos. And a kilo is a kilogram. SI unit for time, we use seconds, minutes, and hours. The true scientific SI unit for time is the second. For force, we use pounds, but everybody else uses newtons. And for temperature, we use Fahrenheit, degrees Fahrenheit. And in most countries, they use the metric system, so they'll use degrees Celsius. But in the scientific community, temperature or change in heat is measured in Kelvin. And notice it's not degree Kelvin, it's just Kelvin. Alright, the next thing is metric prefix conversions. You'll notice that for every base unit, there's a whole list of prefixes that could be attached. For example, you could be talking about kilometers, or we'd say kilometers, or maybe it's micrometers, or centimeters, or millimeters. Well, those are all prefixes, and we can attach a prefix to any base unit of measure. For example, you could have microseconds, or nanoseconds, or kiloseconds, which is 1,000 seconds. And so to convert from one prefix to another, I've provided a prefix chart, and the prefix chart shows you how you have to move the decimal point in order to get to the unit you want. And so I emailed this to you, or maybe I will email it to you. And for example, if you look in the middle of the chart here, this is where the base unit would be. If we're talking about meters, 1 meter. If we want to figure out how many millimeters are in 1 meter, we have to move down the chart. Alright, so to go from meters to millimeters, we go down the chart. When moving down the chart, move the decimal point to the right. And so at the bottom there's some instructions there. So how many millimeters are in 1 meter? To go from 1 meter to milli, we have to go 1, 2, 3 places down the chart. So in other words, we move the decimal place 3 times to the right direction. And so that means there's 1,000 millimeters in 1 meter. What if we wanted to convert from micrometers up to centimeters? So I have a number, maybe it's 15 micrometers, and I want to go up to centimeters. Notice that a micrometer is a smaller quantity of measurement than a centimeter. You can see a centimeter. You can't even see a micrometer. It's so small. So if we have 15 micrometers and we want to go up to centimeters, we count how many spaces or decimal places we'd have to move. We have 1, 2, 3, 4, and that's how many spots we move to the left. So when we go up the chart, we move the decimal to the left. When we go down the chart, we move the decimal to the right. So 15 micrometers, move the decimal over 4 places to the left, and we'd end up with 0.0015 centimeters. So 15 micrometers is actually a very, very tiny measurement. Alright, so that is just a quick run through on metric prefix conversions. Hopefully you have some experience with it. And on the summer review packet, the math review packet, there's some examples. The next thing is scientific notation. Scientific notation is just an easy way of converting very, very large or very small numbers into something that's more manageable, something that you can type into your calculator. If we have a really big number, like the speed of light is 300 million meters per second. Well, to use that a lot and to have to type in 300 million, which is 8 zeros, that gets kind of redundant and annoying. So instead, we use scientific notation. So we use 3 times 10 to the 8th instead of 300 million. Now, your calculator has a conversion mode where you could change this mode so that it always gives you an answer in scientific notation. So if you're not used to using scientific notation, your calculator can help you out on this. So if you have a TI-83 or 84, it looks kind of like this. Just pulled it up here on the screen. Turn it on. For example, we go in here to the mode, and you can see where it says normal is flashing. Right now it's on normal decimal. We can move it over to scientific. So by clicking the right arrow and enter, now we're in scientific mode. We exit out of there. If I type in any number, like the speed of light again, 300 million, and hit enter, it'll change it to scientific notation for us, 3 times 10 to the 8th. Also, if we have really tiny numbers, it'll convert it to scientific notation as well. If we put the mode back to normal, and we type in a number in scientific notation, whoops, 3 times 10 to the minus, let's say, 2. So that's a number in scientific notation, and we're in normal mode. It'll convert it back to standard mode. So your calculator can help you out a little bit with scientific notation going back and forth. All right, and there's some problems on the summer review packet on scientific notation as well. These are some things that hopefully you've got some experience on, and it shouldn't be too difficult to do those problems. Now we're going to go into a little bit on how to measure. And measuring is something that is a little confusing because some people get confused on when to round. And here I pulled up a ruler so you can see that this is just a zoomed in view of a ruler. We have units of centimeters. So this is 1 centimeter, 2 centimeters, 3, 4, 5. And the little lines in between, notice that each centimeter is broken up into 10 pieces, and so we have increments of millimeters. And so if we want to give our measurement, we have to try to estimate where that arrow is pointing. And I know it might be hard to see on this video, but you have to look very close to see where that arrow is pointing. Is it exactly on the line, or is it between two lines? If it's between two lines, we can estimate where that quantity is. If it's exactly on the line, we can specify that in the number as well. Alright, so just take a quick guess at what you think the measurement in centimeters is for A. And we see here that it's somewhere between 1 and 2 centimeters. So 1 point is bigger than 1.5, 1.6, 1.7. Looks like just about 1.8, but it might be in between there. If it's in between 1.7 and 1.8, then we call that 1.75. If it's exactly on 1.8, we say it's 1.80 centimeters. So you can always estimate to one digit beyond the quantity that your measuring tool will measure to. So if we can measure to the nearest millimeter, we can always measure in between, in other words, half a millimeter. What would this quantity be measured as for B? Go ahead and give it a shot. Yeah, it's 4. But is it just 4? Or is it 4.0? Or is it 4.00? Notice that on the previous answer, we said this was 1.75. Or it could have been 1.80. Well, this answer would be 4.00. If you said just 4, you're forgetting the idea that if you use a measuring tool that can measure to the nearest millimeter, you need to specify that in your number. And there's also space in between each millimeter, and you can even estimate in between that. So we can estimate to the nearest half of a millimeter on a ruler or meter stick. This last example is 7.75. So for C, if you guys 7.75 centimeters, you were correct. Alright, so when we get into our labs, we'll talk more about measuring and how to estimate numbers in between there as well. Four-dimensional analysis. This is the last topic, and since I'm doing this video on a computer, I can't really write examples out for you, but on the EduCreations website, you'll notice I've emailed other links to you as well. On that website, I've done some examples electronically so you can see some dimensional analysis examples done for you. But what's dimensional analysis all about? It's a convenient way to convert units. Watching the Olympics this week, you may have seen it, but Usain Bolt, I believe is his name, ran the 100 and the 200 and got gold medals again, just like he did in the previous Olympics in Beijing. And the newscasters were saying that he can run about 27 miles per hour, which is really fast. That's faster than I can ride my bike. And so 27 miles per hour is a fast quantity. That's in English units, but how fast is that in meters per second? Well, we need dimensional analysis in order to convert from miles per hour to meters per second. So dimensional analysis is a way to convert units, and you need to have a way to set up a problem so that we can see the progression of the units and how they're converted. And here are some common conversion factors to help you out in that. For example, 1 mile is 1,609 meters, or 1.609. We round it to, it could be 1.62 kilometers as well. 1 inch is 2.54 centimeters. 1 kilogram is 2.2 pounds. A gallon of fluid is 3.8 liters. A kilogram is 9.8 newtons. There's your measurement of a slug again. Remember, that's the English unit for weight, is 32.17 pounds. So a slug is actually a pretty big unit of measure. Me, I'm only like 5 slugs, so actually not that heavy. 1 centimeter cubed equals 1 milliliter. And so these are all units that you can use to convert from English to SI or the reverse. And again, on the EduCreations website, there's some examples on how to do that by hand. Now, your calculator does this as well. And the calculator program that I have on this computer does not have the Science Tools app to do that, but my physical calculator does. So this is something that I could show you in class. And if I was able to write this down on this PowerPoint, I would, but these are some examples of problems that you should be able to do using dimensional analysis. For example, converting 1 day into seconds. Just having some prior knowledge about time, you know that there's 60 seconds in a minute, and there's 60 seconds in an hour, and there's 24 hours in a day. So to go from a day to seconds, it's really just a multiplication problem. There's two-step conversions, like converting miles per hour to meters per second. 60 miles per hour, well, how many meters per second is that? And last, two-step conversions with exponents. And these get a little bit tricky because you're talking about cubed quantities, and whenever you have cubed quantities, it throws a little wrench in there, and I can show some examples on that as well. If you're handy with your calculator and you want to give it a try, you can use the Science Tools apps on your TI-83 or 84 calculator. It's pretty simple. You go into the Apps menu and you select Science Tools, and it gives you several menus where you can convert different quantities of English or SI units. So you can go ahead and give it a try with the summer homework packet that I gave you, but make sure you know how to do this by hand as well. So that takes us through the measurement slideshow. Hopefully you were able to write down some notes. Hopefully I didn't go too fast or too slow. I do apologize if this is kind of boring. I'm just getting used to doing these videos online. Hopefully after I meet you and I understand your personality better and you understand my personality better, videos like this won't be so boring in the future. So if you realize that you forgot something, feel free to go back and watch the video again. And thanks for watching.